Hello guys, this is Timmy and Yoav presenting you our final project in our Java Algorithms Development course. A brief explanation about our project. During our Java course, we've been asked to build a game, a 3D maze game. In order to achieve that, the whole project was divided into 5 tasks, while each task demanded new skills and knowledge gained through our college lectures, presented by Eli Khalsachi. So let's begin. First, to create and solve the mazes, we used several algorithms. We use the DFS algorithm to build the maze and by that also guarantee that each maze that created has a single entry point and a single exit point. Next, we use the BFS algorithm to solve the mazes. It basically calculates each node's cost and by that it manages to evaluate the cheapest cost from entry point to exit. At last, we've also used the A-star algorithm, which is basically a better implementation of the BFS algorithm. What happens is that the A-star algorithm evaluates approximately the cost from each node to the goal node at every node, using two different heuristic types, Manhattan distance and air distance. To manipulate all those algorithms together, we didn't have to change our code even once. Instead, we used searcher interfaces and strategy patterns, so it will be convenient to the client to choose his wanted algorithm each time. Let us walk through the code. As you can see, the client side is divided into 6 different layers. Each layer has its own purpose. Once the server is running, by entering start command, we run the client side using graphic user interface. At first, we load the properties XML file, which initializes all properties like view type, port, and host details. Once loaded, we can hit the Run Maze button. As you can see, a window popped up. We need to type mazes parameters. For example, so let's generate. As you can see, the maze generated according to client's request and basically we can start playing. Important thing to know is that each maze created has several floors, according to the type parameters. Each floor has its own color, also each floor number is written here on the right. The idea is to help Marco get out of the maze and reach his mother. Next, we have two in-game buttons, Help and Hint. The Hint button moves the game character one step closer to the exit point according to the quickest solutions calculated by the chosen searching algorithms, while the Help button solves the whole maze. Let's see it in action. Okay, cool, you won. Let us demonstrate several clients on one server. So, we run it in the first time. We load our properties file. And we run the second time. Okay, we have now two clients running. We initialize the mazes. Excellent. Our program is using caching system also. You can save solution at any time by pressing the save button. Let's see how the games work simultaneously. Cool, both games won. Now let's try to save the solutions. You can save the solutions in a zip file. Just enter the file name and voila. Let's go see it. Exactly, here it is. When exiting the program, all open sockets and threads are shutting down in order to gain safe exit. Let us walk through the code. Both client and server sides are using the MVP design, which means decoupling the model and view from each other. It means that both model and view are kinds of observables, while the presenter runs as observer. They both work based on notifications, created and sent between the model and the view, while not even knowing the existence of each other. As we said, both server and client operate MVP design. Also, needless to say, that the client's model has nothing to do to any calculations or solving issues whatsoever. Instead, all the data received from the client is being processed into generic notifications, like this, that's sent to the server as is without even knowing what is the current action or its format. When received in server's model, it does all calculations, then immediately returns to the specific data to the requested that was sent. The program can support two types of view. The default view is GUI, and also it can support command line interface. Both the client can easily switch via the properties file. Let's demonstrate. First, we open the properties file and you can switch from GUI to CLI. We save the file. Now we'll load it. Okay, we need to restart the GUI window in order to the CLI will take over. So restart the window. We can load in advance a text file with commands, and then it just reads the commands and according to the same pattern displays the solutions for each request. For example, let's load an input text with some commands and output text for solutions, and we can see that the maze was printed in threads. Okay, we can see some solutions here, maze size, maze solutions, and so on. Also, we can see that it's been asking me if I want to save my solutions before exit. So if I press yes, it will ask me where. If I press no, it just exit and close sockets and threads. I'll just press no, socket close. Okay. Thanks to a generic code, everything is switched and operated easily and user-friendly. The GUI display was built with SWT library jars. Although this library is kinda old, it's very comfortable while using on different operating systems. All you need to do is to switch the SWT jar and voila! Let us walk through the server side now. We start the server by typing the start command. Okay, server started. For connection, we use the TCP/IP connection. We use sockets that uses object output and input streams. One of the server's properties is how many clients are allowed to connect at the same time. Here you can see the number of clients that are connected. For that, we run the server itself in a different thread, and each time a connection is established with some client, it runs in a different thread inside server's thread pool, and that's how it manages to treat each client simultaneously. Let's see it in action. Here is the main thread where the server runs inside. Each time a socket is accepted by the server, it's been added and executed in the thread pool that's been initialized by the number of clients entered. As we can see, the A* algorithm implements the searcher interface. While our game, the maze, implements the searchable interface. So basically what happens is once created another different game, as long as it's implementing the searchable interface, A* will be able to solve it. At the end, it returns an object called solution, which is also a global object to contain solution to every searchable problem. That's it friends, we hope you all enjoyed, thanks for watching, bye bye!